Okay guys, let's continue with 9.8 and we'll look at other ways to use our sum or difference formulas here. And let's look at number 521, number 5 here on page 521, number 5, find sine A minus B. Okay, sine A minus B, again, if I refer to my sum and difference formulas on 520, sine A cosine B, minus cosine A sine B. Okay, so that's what I'm going to use, but then I'm given this information over here, and I want to kind of go through like how we'd use that information to construct our other angles. Okay, so let's look at A. Well, it tells us A is 8/17, and remember that's equal to opposite over hypotenuse. And it's also found in this quadrant. In other words, A is between 0, greater than 0, and less than pi halves. In other words, it's in the first quadrant here, 1. Okay? So I'll draw my triangle. Not to scale. 17, 8. Well, how do we solve for the other side? Well, Pythagorean. 17's my c side here. So 17 squared equals 8 squared plus really whatever x is squared here. Okay, so let's plug that in here. Okay, let me get my calculator up. Okay, 17 squared, 289. That's 64 plus x squared. Subtract 64. $225. And then take the root of 225. And that's going to be 15. Okay. Okay, so I know now my third side 15, and I've got all my sides in my triangle, triangle here, my right triangle. And so 15 and 8 are the legs, and 17 is the hypotenuse. So once I go about using this formula here, I can construct sine of A and cosine of A pretty easily. Well, let's do the same here for cosine of B. Well, it tells me it's negative 24/25, which is again adjacent over hypotenuse. And it tells me also this information that's in the quadrant where it's greater than pi, and remember here's pi, and it's less than 3 pi halves, so that's in my third quadrant. Okay. And I'll just draw my right triangle there. Okay, so adjacent 24, hypotenuse 25. Well, that means my adjacent must be then negative 24 there, because I'm in this third quadrant here, which this information tells me here. Okay, and so once I solve for whatever, say, y here, is it going to be positive or negative? Well, since it's in the third quadrant, it should be negative. So we're going to keep that in mind. So y squared plus negative 24 squared equals 25 squared. Okay, so 24 squared is 576, so y squared plus 576 equals, and 25 squared is 625. Subtract 576. y squared equals 49. That's nice. Okay, and then take the root of both sides. So y equals plus or minus 7. But again, we're just going to use the minus 7 because I know I'm in the third quadrant, and so my y must be negative. Okay, so y equals negative 7. And I can then construct all my angles too, and I could find cosine of b and sine of b. Okay, so let's go ahead and do that now. So sine of A, and again, here's my A, and here's my B. Sine of A would be opposite over hypotenuse. Cosine of B here would be adjacent over hypotenuse, negative 24/25, minus cosine of A here would then be 15 over 17. And sine of B would be negative 7 over 25. Okay, and so that's going to be, when I multiply it out, negative 192 over 425. And then two negatives here make that positive, plus 105 over 425 when I multiply across numerators and denominators. And that gets me to negative 87 over 425. So sine of A minus B is going to be, again, this formula here. And then I constructed my triangles in each of the appropriate quadrants to find the missing side, and then I can construct all my angles from there. And so sine A minus B equals negative 87 over 425. Okay, let's now look at another part of the section. Okay, guys, let's continue here in 9.8, simplify an expression. So let me do one in addition to the one there in the book here. Number 7 on 521, cosine of x minus 2 pi. Okay, so again, we're using the difference formula there, cosine of A minus B, which is cosine A cosine B plus sine A sine B. So cosine of x, remember here's my A, and my B is 2 pi, and the negative is part of the formula, okay? And I'm getting, again, that information from the table on 520, what our difference formula is. Cosine of A minus B, cosine A cosine B plus sine A sine B. Okay, so cosine A, cosine 2 pi, plus sine A, which is x, sine 2 pi, which is b. Okay, remember on our unit circle here, 2 pi is just all the way right back to here. And that's going to be 1 on x, 0 on y. Whoops. And then remember that corresponds to cosine and sine. Okay, so cosine of x is just cosine of x. Cosine of 2 pi would be 1. Plus sine of x is just sine of x. And sine of 2 pi would just be 0. 0 multiplied by anything here makes that 0. So it's cosine of x plus 0, which is cosine of x. Okay. So again, we're going to write our sum or difference formula, identify our A and our B, and then evaluate. And then they may be quadrantal angles like this, or they may be regular angles, in which case we evaluate them all the same, and then hopefully we can simplify at that point. Okay, thank you. Let's now look at solving equations and rewriting formulas. Okay, let's look at solving some of these here. And I'm looking at 522, number 9 here. Solve sine pi fourths minus x minus sine x plus pi fourths equals 1. And this is over the interval of x between 0 and 2 pi. And that may come in useful as we figure out the answer at the end here. Okay. Okay, so first let's use our difference formula here. Sine of A minus B, sine A cosine B, sine A cosine B, minus cosine A sine B, minus cosine A sine B. So essentially this here, I use the sum and difference formula to make that, okay? Minus, I'm going to put it in parentheses so I'm careful to distribute there the negative. And let's now do a sum of A plus B here, sum of x plus pi fourths. So sine of A plus B is sine A cosine B, sine x cosine pi fourths, plus cosine A sine B, plus cosine x sine pi fourths. And of course, that equals then 1. Okay, so that then became this, right? Using our sum and difference formulas again on page 520. Okay. So sine of pi fourths, I know that's root 2 over 2. That's a 45. Cosine of x. Cosine of pi fourths is the same thing, root 2 over 2. Sine of x. Minus, and I won't distribute yet, sine x. Cosine of pi fourths is root 2 over 2. And plus cosine x, sine of pi fourths is, again, root 2 over 2. And that equals 1. Okay, so now let's distribute the negative, and that would then be cosine of x times root 2 over 2 minus root 2 over 2 times sine of x, put it in parentheses if you want, minus sine x root 2 over 2 minus cosine x, because that negative now gets distributed to both terms, okay? Cosine x root 2 over 2 equals 1. Okay, and then I say, oh, cosine x, root 2 over 2 times cosine x, minus cosine x times root 2 over 2 here, that goes to 0. Okay, so those I can cancel out. And then I've essentially got negative root 2 sine of x minus root 2 sine of x. And since they both have the common denominator of 2, I can put it over 2 here, equals 1. Okay. Now, since I have an equation, I can start to use my equation solving skills, and I say, oh, that's all divided by 2. Notice I just have the negatives out up top here. If I want to multiply by 2 on both sides, I can start by doing that. So I've got negative root 2 sine x minus root 2 sine x equals 2. And then what do I want to factor? Maybe I want to factor out sine of x. Sine of x, and that would be negative root 2 minus root 2 equals 2. What's essentially minus 1 root 2 minus another 1 root 2? Well, that's going to be minus 2 root 2, and I've got it multiplied by sine x here, equals 2. Well, I'm solving for x, so I want to isolate x. So I'm going to divide by negative 2 root 2, negative 2 root 2, My 2's will cancel and I'm left with negative 1 over root 2. If I rationalize, then that's negative root 2 over 2. Okay, so let me get a better color here. Okay, so what did I do? Well, once I'm at the point of, say, here, and it equals 1, I've got an equal sign. I combine those two because they have the same common denominator of 2, and I put it over 2. Then I multiplied by 2 on both sides to get rid of that 2. Factored out a sine x, which is in both of these terms. Combine those terms into negative 2 root 2, and then divided them out. And once I divided them out, I still had to rationalize here, and I got to negative root 2 over 2. Now, here's where this information is going to come in handy. Well, where is the sine of x negative root 2 over 2? Well, I know for every 45 or pi fourths here, well, the sine is going to be root 2 over 2 and the cosine's root 2 over 2, right, for a 45. But where are they negative? Where's my sine of x? Because remember, now I'm left with this equation. Sine of x equals negative root 2 over 2. This is solved. I've essentially solved it. But now I have to reason. And I have to say, where is sine of x negative root 2 over 2? And I have to think, well, root 2 over 2 corresponds in sine to my 45s, right? Pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. Well, where is sine negative? In other words, where's my y value negative? Well, y value positive, y value positive. That's where my y value is negative on those two, isn't it? Okay. And so then what are these 45s on each of in the third and the fourth quadrant? Okay. Well, then we say, well, this would be, let's see, pi fourths, 2 pi fourths or pi fourths, 2 pi fourths or pi halves, 3 pi fourths, 4 pi fourths, 5 pi fourths. And then this would be 6 pi fourths, which is 3 pi halves, and then 7 pi fourths again here. So my two solutions where sine, if I plug in this for x, it makes this statement true here. The sine of 7 pi fourths is negative root 2 over 2. And the sine of 5 pi fourths is negative root 2 over 2. So at the end, we need to go back and look at this information here to help us determine if we've done it correctly and we've got it in the right place there. So our solutions are x equals 7 pi fourths and x equals 5 pi fourths, okay? Okay, so hopefully this helps you get started and finishing up some of this stuff in 9.8. And remember, bring any questions you have to our Zoom sessions and we can go over more then. Okay, great. Thank you.